Hello everyone, welcome back to the channel. Today's video will be focusing on CoreUI. First of all, we have to define the list of screens or the available screens that we'll be dealing with in this application. So under the CoreUI, Util creates a sealed class. Let's call it screen. I presume that we have done this approach before in the older tutorials. It has a route. The first screen is the home screen. Data object, home screen. We need to provide here the route for the home screen. As done in the Vuetify application, we have home screen and the product detail screen, wishlist manager screen, product search results screen, and the unauthorized screen. For the product detail screen, the route of this screen is going to be a little bit different, product and the ID of the product. I don't like to hard code things, so let's create constant file. Let's name it constants. I will provide here all the available constants that we will be using across the different parts of our application. Current destination key to handle correctly the process that, as well as products key, search query, products carousel tag for testing purposes, all of this for, I presume, testability purposes or to detect the components for end-to-end test. Let's come back to the screen. I will add here the product ID key. Another screen that we will implement in our application is wishlist manager screen. The route is going to be very simple, wishlist manager screen. The fourth screen is product search results screen. The route will be, let's say, for example, product search and the search query key. That's correct. The last screen is for unauthorized screen. The route of this particular screen will be very simple, unauthorized screen. I would like to add a utility function on screen that will be providing for us the final route. What I mean with that, instead of using this, it will take this in parameter, giving us the final route with the value. And let's call the function path. It could take multiple arguments. It doesn't matter how many arguments going to feed this function with. First, it's going to be string, and it will give us whatever we want here. The return type, it's string. So let's initialize the variable final route with the initial route of this object. And the route is from the screen data or screen sealed class. Already Android autocomplete is detecting or is predicting what I want to do. For each argument, let's declare the key value. Variable final route will be the final route that we have initialized from the route. We'll replace with the value and we want the string value and we will return the final route. We can remove this. Let's define the utility functions that we will be using across the application. It's going to be called helper. I would like to add an extension function on nav host controller. In this function, I would like to apply or call a function before navigating. It takes in parameter screen, the arguments in order to access the full route, optional, and the callback function, let's call it before navigate. Any action that you would like to do before navigating, maybe setting up the current destination, caching some data, we don't know, and it is optional. The route here is screen, and let's call the path function. The arguments has to be pointer args, so we can pass the arguments from here to the utility functions that we have defined. Now let's call on before navigate and let's pass the route as an argument. Finally, we will call navigate. Another utility function that I would like to add here is to access the screen width, screen height. The two values can be accessed from the local context and current resource display matrix with pixels divided by local density, current and density. In order not to repeat ourselves over and over again, we will call a composable function that will be dealing with this. So it's going to be composable function. Let's call it screen width. Sometimes you want to show some stuff according to the screen width. So we need the value of the screen width or the screen height. Local context, current resources, display matrix, width in pixels to density pixels divided by local density, current and density. This is a warning here. Replace with local resource.current. I have never used this, so let's go. With the same way, let's define screen height. I will provide here 4 functions that will be used in the snack bar composable. Basically, I would like to assign a certain color when is dark theme and another color when is light theme. So we will make our life easier. The first one, extension function on material theme. Let's call it success color. If is system dark theme, we have defined already the colors, therefore success dark, otherwise success light. Hence the name of the function success color. Let's do here warning color. On warning color, let's add here error color. The last utility function, it will be used whenever we are dealing with the pagination. In this particular application, we're not going to use the pagination as we have done in the view tree application. We will be using scroll to navigate or scroll to load more. In order to detect that we have reached the bottom of the screen, we need to use the scroll state. Therefore, we have to implement a function. It's going to be very easy to detect whether we are in the bottom of the screen or not. An extension function on scroll state. Let's call it reach bottom. Let's define here a buffer in pixels, and it will give us boolean. If the value is more or equal than max value minus the buffer basically is a tolerance, if you will. Then we're going to say that we have reached the bottom of the screen. I think that's pretty much it for the helper functions that we will use across the application. One last thing to add under Util package is the media query. The main reason behind implementing media query is on the home screen. We need to handle multiple sizes of the screen, more specifically in the grid layout. What I mean with that, the number of items per a certain row has to be dynamic. For small screen, we're going to show only one item per row. And for example, if our application is running on a bigger screen, tablets or whatever, we can increase the number of items per row dynamically. Thus, we have to implement the media query. Under Util package, add another package. Let's call it media query. It's going to be very simple. First of all, let's define the screen size. It is an enum class. Call it screen size. We have small and medium, large and extra large. For the implementation of the media query, we have to add one function that's going to give us the screen size, and it will return the screen size. Let's add a new file. Let's call it media query. It is a composable get screen size. It will give us screen size enum. First, we have to get the screen width. We have already implemented a function. It's called screen width, a simple when statement. If the width is more or equal than 840, we are talking about large screen. Let's say the proposition. That's correct. That's 100% correct. That's all we have in the Util package. For the next video, we'll be implementing the image composable, the discount Lute animation composable, and the warning message. I hope you liked the video. See you in the next one, and happy coding!